even going to ask if you guys want number 1 because I think we need to review. Okay, so on this one, if you tried factoring nicely, do any of our factoring techniques work? No. If it's 4 terms, we usually try grouping, but that's not an option.
Yeah, I'm in class.
What? John Paul. Did you tell her I'd be back down later?
Yeah, around 3rd or 4th hour.
So, to find our possible zeros, we have to do our P's and Q's. Remember, P comes from the constant. It's everything that divides 2 evenly. And you have to include every possible combination. So plus and minus 1, plus and minus 2.
I completely switched them.
Q comes from the leading coefficient. So everything that divides 4. Plus and minus 1, 2, and 4. Then to get our possible zeros, that's P over Q. So 1 over 1 is 1. 1 over 2. 1 over 4. 2 over 1 is 2. 2 over 2 is 1, we already have it. 2 over 4 is 1/2, we already have it. So these are the possible zeros. Now that's not actually every zero, those are the possible rational zeros. So it doesn't include radicals or imaginaries or things like that. Once we have those, how do we find out which one is a zero? Plug it in. You're plugging it in and you want it to equal what? 0. So you plug those in. Tell me one that worked. 2. When something works, once you find that first 0, then we can do synthetic division with that 0. So we know our coefficients. If you're missing a power of x, what do you have to include?
0.
0. So the 4 comes down. 4 times 2 is 8. Negative 4 plus 8 is positive 4. 4 times 2 is 8. Negative 7 plus 8. 1 times 2 is 2. Negative 2 plus 2 is 0. So we get 4x squared plus 4x plus 1. Now we could just find another one of our zeros that worked, or it's more time efficient once you get to the point where you can factor it, just to go ahead and factor this. So we could do slip and slide. What numbers multiply to 4 and add to 4? And then we need to divide those by 4. So we get 2x plus 1, 2x plus 1. So my zeros, if I set those equal to 0, we get negative 1/2 twice, so we can say negative 1/2 multiplicity of 2. But it was originally degree 3 because we had a cube. So that means there should be 3 zeros. How do we get the last one? Yeah, the one that we did our synthetic with. Were all of these numbers on our list of possible zeros? Yeah. Okay, and then part C said write the factored form. So that's when you say f of x equals, we have the 2x plus 1 twice, so we could say squared, and then we have a x minus 2 because of the 2.
Now that I'm looking at it, it makes so much more sense than it did.
Good.
I know how to do this, I just don't remember how to do it.
Yeah, I was going to say, when we did it, you guys did it very well. It's just a matter of remembering.
Bad brain for remembering.
Let's look at number 2. So we have a rational function. So part A is factoring. X squared, we can't really do anything to, but the bottom could factor into x plus 3, x minus 2. X and y intercept. An x-intercept, just like with a line, is where you hit the x-axis. So that means your y is 0. So if you set your fraction equal to 0, you would multiply over the bottom. So it's really just when the top of this fraction is 0. And what makes x squared equal 0? 0. So our x-intercept is 0. Y-intercept. To find that, that's when x is 0. So if you go back and you plug in 0 for all of your x's, you get 0 over -6, which is just 0. So x and y intercepts are both 0. Then we did asymptotes. Asymptotes are lines, so you have to give me a full equation for them. Otherwise, I will take off on that. Vertical is what makes the bottom 0. A vertical line is x equals. So that's why we factored it. What makes x plus 3 equal 0? And what makes x minus 2 equal 0? All right, and then we have either horizontal or oblique. You can't have both. To decide, we go back to the original and we look at our degree. What was the degree of the top?
2,
And the bottom?
2.
If it's the same degree on top and bottom, how do we get it?
There's, no.
Yes. It's a horizontal, you divide your leading coefficients. So 1x squared over 1x squared would just be 1. So this has a horizontal, y equals 1. Remember, if the top has a smaller degree, it's an automatic y equals 0. If it's the same degree, it's y equals 1. If the top is 1 bigger, that's when you have oblique. And how do we find an oblique asymptote?
Long division.
Long division. All right, now we can graph everything. If I have you find this stuff, I am expecting you to include it on your graph. So we have a vertical at -3 and +2. Horizontal at 1. X and y intercepts were both 0. Then when you put this in your calculator, I always recommend going back to the original. Do parentheses around top and bottom just to prevent error. Or use the fraction feature so you can make sure it's typed in exactly how you want it. When you draw this, remember, it's a function. So first of all, is something like that going to cut it? No. First, that one doesn't even approach your asymptotes. So as you're drawing it, you have to be getting closer to your asymptotes. I don't want to see this either, because that's not true. It's curved, and this isn't even a function. So I'm kind of picky there. You need to draw a curve getting closer to your asymptotes as time goes on. And so it should look like this. Is that one okay? Number 3, you should have gotten plus and minus I plus and minus 3/2. Do we need to work that out? Yeah? Let's take a look. So if we do slip and slide, okay, x to the 4th would break into x squared. What numbers multiply to -36 and add to -5?
9
But we start out multiplying by 4, so we have to divide the 4. So we get 4x squared minus 9 and x squared plus 1 equals 0. So if you set each to 0, we get 9/4 and -1. How do we get rid of a square? And with it? So square root of 9 is 3, square root of 4 is 2. Right here, square root plus and minus, square root of -1 is I. And you could always check those just by plugging them back in.
I split the 4x minus 9 into 2x plus 3.
That's fine. Yes, that was still a difference of squares, so we can factor further.
Oh, what were the rules for like horizontal and oblique asymptotes again?
If the degree on top is smaller, horizontal y equals 0.
Okay.
Because it's kind of like saying, how can you divide? Like, what would your quotient be when you divided them? The quotient without the remainder. So if the top is smaller, you can't divide them, so it's 0. If it's the same degree on top and bottom, you can only divide that first term, so it's just the ratio of the leading coefficients.
Okay.
If the top is one bigger, then when you divide them, you will get a line. So that's when you have an oblique, and you have to divide it out.
Okay.
All right, number 4. Let's see what we need to work out here. A, you should have gotten x equals 2. You actually got -5 and 2, but you have to check them, and they don't both work. B, -3 plus or minus the square root of 29 over 2. C is +4. You also had a 3/4, but when you check, it didn't work. And D, 5/3 and 3/2. Do we need to work out any of those? Let's look at C. So the square root of 3x plus 4, say plus 5, equals 2x plus 1. So if I'm trying to get this radical by itself, what would we do first?
Subtract.
Subtract over the 5. Okay, now to get rid of the square root, we square. But when you do that, you have to square the entire side of the equal sign. So the square root and square cancel. Over here, if we write it twice in FOIL, we get 4x squared minus 16x plus 16. Set it equal to 0, so if we subtract over the 3x, subtract over the 4, what would we have to do at this point? Flip and slide. Okay, what multiplies to a +48 and adds to a -19? Mm-hmm. Okay, divide by 4. So we get x minus 4, 4x minus 3 equals 0 for our factored form. When you set those to 0, you get 4 and 3/4. But any problem with a square root, you have to check. When you're checking, you put it back into the original problem. So if we put in a 4, we get the square root of 12 plus 4, so the square root of 16 plus 5 equals 8 plus 1. So 4 plus 5 is 9, 8 plus 1 is 9, so that works. If we put in a 3/4, then we get the square root of, so if you put in a 3/4, we get the square root of 9 over 4 plus 4, so 25 over 4 plus 5 equals 3/2 plus 1. So 5/2 plus 5 equals 5/2, and is that going to work? No. So that one did not check, so we throw out that answer. So 4 is the only option. Are there any others on problem 4 we need to look at? And problem 5, you were just writing, going back and forth between an exponential and a log. So the first one would be log base 5 of 1 over 625 equals -4. Second one would be e to the third equals x. Do we have questions on either of those? Then you can work on that next chunk. So tomorrow we'll talk about 6 through 20.